Hi, this is the West Group's prototyping video, and it will demonstrate as it is wired for 2 sockets and 4. The reason we did a 2-socket video is because you'll be able to see the wiring a little bit simpler just because there's only 2 sockets wired. You can pay attention to the 4 green LEDs on top. When an LED is lit, that means it is selected, and the red LED that you'll notice whenever it is lit, that means there is an error. That means that there are 2 selected at the exact same time. On the bottom here, I have our microcontroller fully wired up. As I said, in the 2-socket video, you'll be able to see that a little bit clearer as we go through. But in the 4-socket video, you'll see the full operation of being empty going all the way to full as we drop them in there, and it sends signals over to the torque controller receiver. But without any further ado, thank you. 3.3 volts is brought into the voltage rail across all of the switches from the socket tray transmitter board, and from there you'll see with the yellow wire it is brought through the holes to the other side of the board. On the other side of the board, the yellows connect to the bottom of the snap sensors, where the snap sensors are then brought through via the blue wire, and the blue wire then goes into the digital input pins of the socket tray transmitter. The green wire you're seeing is connected to the ground leg of the LED, and there's also a red wire running through there, which is your positive side. That way, whenever each switch is actuated, it takes both switches to be actuated to turn on the LEDs. Over here at the torque controller receiver, you'll see that all of our digital pins are being used here to output onto LEDs. In the finished product, we're hoping that each of the digital pins will actually output a binary signal into what we have here, the MAX 485, which will then translate that binary signal into RS-485 code for the SDIC torque controller. I didn't mention this on the other one, but here you'll also see our HC05 Bluetooth receiver, and over here the HC05 Bluetooth transmitter. These are connected through the TX and RX pins, as well as 3.3 volts power. An added addition to this one was adding a resistor from the ground rail of the LEDs over into our ground pin over there. We were actually drawing too much current, which was causing our HC05 to blink off during power up. You'll also see the pull down resistors on all of our digital pins to prevent any antennas from showing up. Thank you.
So for this, we'll be seeing how each of the sockets go in. So obviously that bolt there fills the hole, the LED shuts off. And as a mechanical prevention of fitting the wrong one, a too large socket cannot fit in the hole. The proper size can slide down in there, turning off the other LED, once again showing the mechanical error. And once a socket does turn off the LED, you see the LED light up over there on the torque controller receiver, kind of flip-flopping it around in there to show how each can be sent as a signal over there. You see the LEDs turning off on the socket tray, showing that it is in place. And we have it kind of roughly connected on the bottom there. In the final design, it will actually fit completely under the socket tray. There will be 2 socket trays for a total of 8. So it'll give it enough room to actually sit down in there. There's our power rail, the yellow, the in-between wire, and the full controller receiver circuit there.